Hey, Mr. McLaren here. So I am going to be going over the Plate Tectonic CER Thursday, Friday. This video is going to be the optional tutorial. You could watch this and after you've done yours, you could, if you're getting completely stuck, watch this and follow along. Or, you could kind of pause this after you've gone what you need and then kind of check later on to see how you did. There's a number of ways you could use this. It's kind of up to you. I'm just gonna basically do the CER and use the resources as I've said in these instructions. So like last time, the score on this assignment is I'm gonna be using the rubric to score you on how you're doing, but you'll get credit for the assignment if you just do the assignment. So don't worry too much about the score. I'm not like expecting people to get 100% scores on this, though last time a number of people did, so we'll see. Okay, so first things first, there's a couple slides at the end. They're just resources. I've color coded a little bit. This should actually be highlighted. I think I did that on one version, but not all of my ones like this. So I've got the definitions and I've done a little bit of the color coding to help remind you of what colors mean what. Also, one thing that I've tweaked a little bit is I've started to call this dark blue the procedure, because that's basically what we're doing here. You're telling me how the data was collected, which is in a science like typical lab, that's like what we call the procedure, or like, if you're in a cookbook, it might be like the steps that you need to do with the ingredients, essentially. There's also the sentence frame here. You don't have to use these, but these are little like fill in the blanks, like kind of like a Mad Lib if you've ever done one of those. You could say, I observed this when that happened, or something like that. Like I saw this when I did that, like cause and effect essentially. So there's a couple different claims that we could do there. Here we're referring to data. And then you could say, I'm looking at this evidence here, right? So you're kind of specifically calling out what your evidence is. And then your reasoning, this is more talking about this is going on because of this. So you're talking about like your big ideas, your conclusions, your scientific terms, all that stuff. This was also just to remind you how the color coding was done. I'll kind of refer back to that as I'm doing the color coding. And then you have the actual rubric for the assignment itself. So the vocab words are tectonic plate and continental drift. I expect you to use those two terms. And then there's also these colors that I'm expecting you to use. There are numbers in this prompt, so you should be using some orange in your evidence, basically. Okay, so if we're looking at this, I just went over those like back to the slide things. We need to basically pull up a number of different assignments from this week, and those are going to be our pieces of evidence. You might be able to also use other pieces of evidence, but that's going to be our first primary source. So if you look here, these are three things that we need: the plate tectonic CER Monday, Tuesday, and Wednesday. So there's a number of ways that you can get to that, but if you open up a new tab, you go to the little waffle iron here. I know a lot of people call it that, and I love it. I love the waffle iron name. So you can go to your drive. If you've got things organized into folders like I do, you could go exactly to the week or the assignments for that week. I know a lot of you guys don't do that, but if you had it organized like that, then it's like all in one place. Let's say that you don't organize your drive. Like, if you needed help with that, I think the Avid had a number of videos around that. I might be able to link those somewhere. But if you look in the search bar here, you can search in plate CER, and then I'm gonna want Monday, I think. Yeah, plate CER Monday, it's right there. Okay, so I got the plate tectonic CER Monday. Good, and then plate tectonic CER Tuesday. Okay, and that's right there. Plate CER, I'm gonna get rid of that, go with Wednesday. And that should pull up all of the three resources that we need. So if you go to your drive, just to review, you need to be typing in the search bar. As you're typing in, it might pop up underneath. As you keep on typing out, you can hit enter though, and it should search it. So if I did like plate CER Tuesday, and then like hit enter, it will give you a search of things that are related, but usually the first thing is what you're looking for. You do need to be a little bit careful. You can also look at like when they were last modified and search for like the most recent one that you've been working on. That's one other way to find out which one is the one that you had work on. I know that people have a lot of copies in their drive right now for assignments, so a little tip there. So I've got these 3 assignments. Okay, Monday, Tuesday, Wednesday. I'm gonna be looking at those. I'm gonna kind of reorder them to help myself think about them as I go through the CER. So I've got those all opened up, and I think I'm actually ready to get started at 6 minutes in. So Continental Drift, this is our claim. I think, yeah. I've forgotten how I want to write this ultimately. I'll probably have one of these 2 on there. It's probably just going to be this one. I'll probably just give you the claim. Yeah, let's just do that. And I'm going to, at least in this video, give you the claim. So we're saying that the Earth's continents are moving, but that's not due to them floating on the ocean. You know, this is really due to continental drift. We'll go over that more later on, but we don't want to say too much more right now. We don't want to go into that reasoning or anything. So for our first piece of evidence, this is the plate tectonic CER Monday, which was Wegener's puzzling evidence. So if we look here at this activity, I've tried to color code the activity. You should be able to watch this video and then write down what you saw and who saw it in their procedure. I'm not going to do that right now in this video. I'm just going to refer to some of the other stuff that I have laid out here for you. Here's a little reading that kind of summarizes some stuff, and I've color coded it for you as well to help you pull from that. And then this also is something where you can kind of rearrange these pieces and try and get them to line up so that you've got like similar fossils next to each other. So you're trying to basically move these things around and rotate them. And like if you're done with this, I'm gonna just kind of do this really quick and show you what it looks like when I'm done. Okay, so this is what I've got when I arranged the fossils so that the similar fossils were together. And you can kind of also see how a lot of the continents, their coastlines line up in a strange way, especially when you look at those fossils. So this is our main piece of evidence, is what Wegener saw. Was he saw fossils on different continents in a weird way that seemed to line up with the especially South America and African coastlines. They just seem to really fit very well together. And then also you have fossils of the same thing like thousands of miles apart in the modern history, but it looks like they went together in the past. That's the main idea of what we're seeing here. And then this is basically what I just said there, that many fossils were thousands of miles away from each other. These lined up when the coasts were put next to each other, such as the I'm gonna probably add this in to the actual thing because I need to, such as the east coast of South America and the west coast of Africa. So this information, this is basically what we're taking and putting into the CER here. So you could honestly, I mean, not exactly copy and paste this, but put it in your own words. But this is basically what we said. So we could say that Wegener's analysis is our source here. So the scientist Wegener analyzed a lot of fossils. So that's basically our source. And then we can say kind of what he did. And this is honestly kind of good from here. Like I've basically told you, okay, the scientist Wagner analyzed a lot of fossils, and I told you what he did. He went to these various sites. He then mapped out wherever he found them, and he looked for patterns, and he found that many of these fossils lined up on continents thousands of miles away. And they lined up on when the coasts were put next to each other, such as the east coast of South America and the west coast of South Africa. So there's no numbers really that we can give there per se from at least the part that I used in my evidence. There may be some actual numbers that you can get from this video. In that case, you would also have the orange there. But I think that this is pretty good from that first source. That's like totally fine. For Tuesday, for this one, I think that you might be able to get a little bit of... Yeah, this one is... There's some numbers, but not a whole lot. This also has some stuff with the reasoning. So this slide is basically all around the reasoning, so you could refer back to this more when you get to that reasoning piece. So let's see, let's have a look at this. If we're looking at this map, yeah, there's some information here about the 33 kilometers showing like a certain depth. Actually, I honestly could color code that. I probably should do that for you guys, so give me a second, I'll do that. Okay, so that's all the colors added there to the explanation about how these dots were collected. So that's basically some of our data. Now we could look at like thousands of data points and give some information, but that is just too much. So what we could say here is that to me, it looks like these earthquakes, we're seeing a pattern of where they're happening. It's not just random over the planet, it seems to be along these lines. So I'm seeing what appears to be lines of where these volcanoes are happening or where they're originating. That's the main idea of what I'm seeing here, and that's probably something like what you would say there. So I'm going to type that out here. So the scientist... Actually, I think I could probably copy paste some of the information, and yeah. This, because we basically are saying this information is coming from this guy right here. So we'll say the scientist found a clear pattern. I'm gonna change that. That's not italics anymore. And it's black as well. In the earthquakes. So we could say like yeah, like that's pretty good for this procedure. Again, if you could write this in your own words, that would be great. In the, I would say the origin of the earthquakes, actually, I should probably say. So that was who collected the data, that was kind of like how they collected it, and then what did they see? So this would be our purple, this is our actual observation. When we look at the data, the earthquakes are not randomly happening. They appear to happen along lines that cross oceans and continents. Some areas appear to have more earthquakes than others. For example, like I'm seeing there's a lot of the blue dots. They're talking about these like deeper earthquakes. They're showing some of these depth of the earthquakes, but it looks like you can see that there's some really deep earthquakes, and there's a whole lot of them. It looks like right around here and right there, right? You can see a whole lot of deep earthquakes, and a lot of them along like basically the Philippines and Japan. There are a lot of deep earthquakes ranging, what was the depth that they said? I see a lot of green, mostly 70 to 300 kilometers. So I'd say there's a lot of deep earthquakes, and these are particular units that were measurements, so we should include that. So there were a lot of deep earthquakes around Japan and the Philippines. Is that how you spell it? I always have a hard time with that one. Yeah, there we go. We can also see a clear line of earthquakes in places like the West Coast along America, like California, a lot of it, and then a little bit off the coast and into Alaska. The West Coast of the United States. So that's like basically what we saw there. Okay, so we got our first two things basically written about. And then we need to do our Wednesday. I don't know why this is Monday on it. It should say Wednesday. This is what happens when I rearrange all my pieces of evidence. I'm like, what day was what? Okay, so for Wednesday, if we look here, there is, oh look, we got some, this is the age of the ocean floor. So they, oh yeah, I remember this one. And there was this video. Oh yeah, I really liked that video. It told you about the ships and showed you the ships. Oh yeah, this one's cool. Okay, so for this one, it looks like this data was collected by a lot of international organizations. And honestly, just for the sake of time, I'm not going to write all of that out again. I'm just going to plug and play. I would like you, if you can, to include some of the names of the ships that they talk about in this video. That would be really nice if you could do that. Like I said, I'm not going to do it myself right now. Just for the sake of time. And then if we're looking at the data here, it looks like some places there's very, very new ocean floor, and it looks like along this ridge line here, along that ridge line there's very young ocean floor here, and then there's some very old ocean floor in some places like right here. So I'm going to be focusing mostly on this right here because this is so striking. You can very clearly see that there. You can also see it pretty clearly off of the west coast of the United States as well. But it's very, very clear here off the east coast of the United States and between like Europe and Africa. So we're going to talk about that sea line ridge. So let's make this, maybe we could make that be a different paragraph. It just feels like that this is a little bit different. I know we're going to start going into the next page, but we can also shrink down the font. That'd be fine. That'd be fine with me. I know it's kind of hard for you guys to read it though. So let's say, I'll try and say it out loud though when typing. This is gonna be our observations. If we look at the sea, what's it called? the mid-Atlantic ridge in between America and Europe. Well, it's like the Americas and Europe / Africa. Between the... Come on, McLaren, you can spell better than this. Okay, I think now I'm just being trolled by my keyboard. Okay, if we look at the mid-Atlantic ridge between the Americas and Africa, and we see younger sea floors the closer to the ridge you get. For example, near the ridge, we have some samples as young as if it's red, it's definitely 10 or less. So it's 10 million years or younger, around there. Samples that are younger than 10 million years old. Gosh, come on, spelling. This is indicated by the red color in the key of the map. Also, as you get further from the ridge, the age of the sea floor increases, and until you get near the US coastline, and some samples are as old as what was it? That blue or even purple. There's actually some deep purple there. That's like over 280 million years old. That's very old. 180 million years old. Yeah, okay, so that's our 3 main pieces of evidence there. Small typo here and there. Come on, there we go. Again, you can make this font a little bit smaller. If you could do that for me, I would really appreciate it. Again, you can highlight all of this, and then if you go up to the font size, you can make this bigger or smaller. I just would like to be able to read this on the slide when I'm doing the grading. It just makes it a lot easier so that I don't have to download it into my own drive as a PDF and then open it as a, yeah, it's a lot more work. So if you could please make it so that this all is on the slide, that would really, really help me. So we've got all this evidence. We've got kind of these observations here. I think I also need to do some numbers. And the 10 million years old. Yep. Something like that. Okay. So here, I think we've got all of that evidence. Now we need to talk about continental drift and plate tectonics and what these things are, these tectonic plates. So this is, I'm trying to figure out if I'm going to do this before we've done a lot with plate tectonics or kind of in the middle and then have us come back and fix up this reasoning. I'm not sure. But this is what I'm planning for, maybe us just doing this as like a first pass. So if I'm looking at the this prompt, our claim was that the Earths are continents, but they don't float on the ocean. So I could say I'm gonna just change this so that this is black. It bothers me a little bit when it's the red on the white for no reason. The Earth's continents are drifting due to our tectonic plates colliding with each other. These plates are constantly moving, which causes them to rub up against each other. This can cause earthquakes, and we also see many volcanoes along these fault lines between the tectonic plates. Something like that. This is the main idea. You're explaining what tectonic plates are. You're telling me what continental drift is. I'm bringing in some of the evidence right here. Like you can see I'm talking about the evidence in volcanoes. That's some of my evidence. I'm kind of talking and referring to that and tying it into my claim. You can also, we should probably also talk about these fossils and how these things line up. There is also strong evidence that all of our continents were once together, and that plate tectonics have pulled them apart, and in some cases made continents collide. And then we could say, you know, Wegener studied fossils and built off of other scientists' work comparing the coastlines to propose these used to fit together. He thought the continents were floating. Yeah, I'm gonna have to fix up a lot of, I'm not a very good typer, as you can see. So he thought the continents were floating, but we now know that is not the case. We can use a number of technique, or a number of, let's say, methods to measure the age of the sea floor. When we do this, we can see the age of the rocks near the mid-Atlantic ridge. It appears that new rock is being formed at the ridge, pushing the old rock away. This can actually be observed nowadays directly, but the sea floor record has been measured for a long time. Something like that. So that you're basically you're talking about all these pieces of evidence and why they're supporting this idea that these things are moving. So here you can see I'm talking about how this stuff is showing that this old rock is getting pushed away and it's moving. So you could say in reality, the continents are just riding along the tectonic plates, or something like that. Which makes them appear to have moved. Something, just kind of explaining the main idea here. So I think I need to also highlight my tectonic plates here and probably also capitalize them. Yeah, because these really are, big proper scientific terms. It's like the name of a book or like a important person, Gotta give that title recognition. Gotta show some respect, right? Trust me, tectonic plates has earned that respect. And for the longest time, this theory was really rejected by a lot of scientists. They thought it was just like so crazy, but then the evidence just kept on being too compelling for them to say that. I think I may have not said the word continental drift. I need to throw that in here somewhere. It should be easy for me to throw it in because I've talked about it a lot. So hold on, just give me a second. Okay, so he thought the continents were floating, but that was not the case. His theory was called Continental Drift, which is now replaced with the tectonic plate model. Yep. That looks good to me. All right, I think that we need to label that, essentially debunking that is part of this reasoning. All right, I think that that's everything for this. I know it's a long one. As I said though, you could just kind of look at what I've got here and just kind of copy it at the very end of the video. So I'm gonna make sure that this is not in the way, right? Get out of the way, McLaren. So you can see that font. Good deal. All right, I'll see you guys around. Take care, everyone.